In this module, you will learn to prove and apply the midpoint theorem. The line segment joining the midpoints of the two sides of a triangle is parallel to the third side and equal to half the third side. Let ABC be the given triangle in which P and Q are midpoints of sides AB and AC respectively. We have to prove that line PQ is parallel to side BC and PQ is half of BC. Draw a line CR parallel to BA such that it meets PQ produced at R. Here, we'll prove that the quadrilateral BCRP is a parallelogram. Let's begin with the proof. By construction, we have drawn CR parallel to BA, and from the figure, AC acts as a transversal for them. This implies angle QAP is equal to angle QCR, as they form a pair of alternate interior angles. Denote this as equation 1. Also, AQ is equal to QC, since Q is the midpoint of side AC. Also, angle AQP is equal to angle CQR, since they form a pair of vertically opposite angles. Thus, two angles and the included side of triangle APQ are equal to the two angles and the included side of triangle CRQ. Thus, by the ASA congruence rule, triangle APQ is congruent to triangle CRQ. Now, since the corresponding parts of congruent triangles are equal, PQ is equal to QR, or PQ is equal to half of PR. Also, AP is equal to CR, but AP is equal to BP, since P is the midpoint of the side AB. This implies BP is equal to CR. Also by construction, BP is parallel to CR. Thus, in the quadrilateral BCRP, we have a pair of opposite sides, BP and CR, that are equal and parallel. This implies quadrilateral BCRP is a parallelogram. Now, since opposite sides of a parallelogram are parallel, PR parallel to BC, or in other words, PQ parallel to BC. Also, opposite sides of a parallelogram are equal. Therefore, PR is equal to BC. Therefore, half of PR is equal to half of BC. Or, PQ is equal to half of BC. The converse of this theorem also holds true. It says, the line drawn through the midpoint of one side of a triangle and parallel to another side bisects the third side. That is, if, in a triangle ABC, P is the midpoint of AB and PQ is parallel to BC, then AQ is equal to QC. In this module, you will learn to prove and apply the midpoint theorem. The theorem says that the line segment joining the midpoints of the two sides of a triangle is parallel to the third side and equal to half the third side. The converse is as follows. The line drawn through the midpoint of one side of a triangle and parallel to another side bisects the third side.